I'm Scott L. Miller. Welcome to Sam IT, and today I'm going to be addressing a question that came up recently in the community that I participate in. And that question is, I have a file server, and that's not really too applicable, but it's kind of important to the context. I have a file server, and I need to store different groups of data that are all relatively large. I have a single underlying RAID system, so there's a single physical array that we're dealing with. Should I split up the file serving data into separate volumes, whether that's being split by the RAID controller, split by an LVM, or split by partitioning, doesn't really matter. The question is, should they be split, giving us an opportunity to run independent file systems in these different partitions? In this question, it was really about 2, but it could apply to 2 or 20. It doesn't really matter. The question is, should you be splitting them up? So generally, we can give a really quick answer to this. The answer is no. Very rarely would you want to split them up. So it's not a hard and fast answer, but it is the common answer. In most cases, you will not want to even entertain the possibility of splitting up your volumes or your partitions or your volumes, whether it's from the RAID controller or from LVM. It doesn't matter. You're going to want to keep that all together. But why do we feel like we want to split it? This is something we should look at because there are reasons here. There is history here, and understanding why we used to want to do it, why we probably don't want to do it anymore, is important in understanding how to address this question. So let's start with performance. It's the most important reason we would typically split these things up, and it has some value. If we split up our volumes, potentially we're able to manage multiple queues going to those things. That's kind of valuable in a very esoteric sort of way. The reality is that your computer is really smart today, and faking multiple queues to the same physical device is not going to provide much benefit, if any, and has a lot of opportunity to create problems. You have a single underlying physical device. You really want the computer to understand what that device is doing and not confuse it, which in most cases you won't, but you don't want to attempt to confuse it for the purpose of manually managing queues when the computer already knows how to manage the queues for that device. There's a lot of technology has gone into that. There may have been a time period where that is true, and I've seen some good math behind that long ago. Those things have broadly changed in many different ways. So doing that today really doesn't make sense the way that it used to. There is a belief that there is a performance gain from this because you're able to operate across multiple volumes at the same time. This is a myth, however. What this comes from is long ago, typically 20 plus years ago, but that's when many of the things we know today were learned. Typically, we actually had separate physical devices under the hood, whether it was multiple drives or multiple drives in RAID arrays and then multiple RAID arrays. When we address those things by having separate file systems on them, we were actually addressing separate physical devices, each with a physical bottleneck. And by having more than one, we were able to dramatically increase throughput in many ways. Not only were the SCSI cables no longer saturated, but the drive heads were able to move simultaneously rather than sequentially, and able to address different types of data under different scenarios. We were also able to carefully tune the hardware and say perhaps one file system for a file server was better addressed by RAID 5, while another was better addressed by RAID 10. We could do those things because they were separate physical devices. Today, in this example, and in most cases, we're not dealing with separate physical devices, but a single physical array, and that array has the same behavior across all of it. So separating that by file system, again, doesn't make sense. It is worth noting there are very, very special case scenarios of which you will essentially never see, where it is possible to apply quality of service to different file systems, and they require the volume level separation in order to get that performance tuning so that one request is prioritized over another. That, however, is completely at the logical layer, and if it is impacted by the fact that you have logical volumes or partitions separating your data, means that it's logical but not aware of that data, and there's definitely a better way to handle it. So we would hope that that is not what would happen in general, but there's reasons why it could in theory. It's much like the discussion of when you need quality of service, should you do that at your network layer, or should you separate your network by VLANs and then apply quality of service to the VLANs? Universally, applying it to VLANs is lazy and ineffective. It's not how it's meant to work, and it doesn't make logical sense, but it's what people do quite often because it feels natural and it seems like an easy way out. The same thing would apply here. There are better ways to prioritize the data that's important without forcing you to manually partition or volume your data apart. So from a performance standpoint, assume there is no performance gain by doing this, and assume that if there is going to be a performance impact, that it is going to be a negative, a tiny one, almost certainly, but a negative. There's more overhead to having to run multiple file systems and maintain that volume or partition layer. Again, absolutely tiny, but it's not actually zero. Okay, the next up is stability. Back again 20, 25 years ago, file systems were wildly unstable. Of course, so were the hard drives that they sat on. Both of those things have changed, but the physical hard drives being stable or unstable is not really a factor in this discussion because we're only dealing with a single physical device regardless of what we put on top. But from a software perspective, we used to have a problem, and this is not specific to any operating system or file system, so it doesn't matter if we're talking Windows or Linux or whatever. Back in the early 2000s and previous, file systems had a tendency to be less than stable. Some were far more stable than others. It is not an absolutely universal thing, but almost always your file systems were a point of risk, and we worried about letting them get very big because the bigger they were, the more likely they were to run into a condition where they would corrupt at a software layer, not a hardware layer. That as well being a risk. And so we had a tendency to want to isolate them by making our file systems smaller so that should a file system corrupt, we would only need to address the data stored on that specific file system, restore that, and get back into business. So our restore or restoration domain was smaller simply because we broke it up. In theory, that could still apply today, but file systems have become wildly stable. They are so reliable that the idea that your file system itself would fail seems alien. We don't think about that at all, but 20 years ago, it was a common thought. Oh my gosh, my file system could fail. NTFS, I'm going to lose all my data if you go above a certain size. I need to isolate that. I need to protect against NTFS failure. Today, of course, NTFS could handle any size, anywhere, and you could run it for 100 years on 100 different systems, and you would expect to never run into a condition where NTFS itself had failed. Could it? Of course. But the chances of it have become so astronomically low. So that fear, while it still lies under the hood, a lot of people still feel that worry that their file systems are too big. It's not really applicable today. It's just an emotional response, and we are not necessarily aware of the fact that it's actually changed. We don't normally think about it. We feel that things have gotten bigger and more stable and work better and they're faster. But we don't always realize that that specific artifact of file systems were unstable and now file systems are stable has actually changed, and now our behavior can reflect that in a conscious way. It doesn't just have to be a subconscious way. Next is file system maximum size. When I started in the industry working with Linux and Windows and Solaris, because I started in systems administration in 1994, when we talked about file systems, one of the most important things we would talk about was how big the maximum size of the file system could be. We also worried about how big the maximum size of individual files could be. These are things that seem crazy to have to think about today, that depending on the size of hard drive you've purchased, you have to change which file system you're going to apply, and you may have to take your files and break them up or store certain type of files on specifically different devices with a different file system that can handle really large files. That seems absolutely nuts, but 25 years ago, that is how we looked at nearly every file system decision, and we had to do really crazy things like having many separate file systems for large devices like file servers so that we could minimize the size of independent file systems as they may easily overgrow their maximum capacity. Today, we don't have to worry about that at all. Today, we simply can put the biggest file system we need on whatever device we have, and it never really comes up. And we don't have to worry about the file sizes either under any normal circumstance. So this has gotten really easy. So that has not just kind of gone away for the most part. It is absolutely gone, But again, that is something that a lot of people internalized, that feeling that they needed to break things up, and it has carried on whether we teach it to people because and they don't question why we do it, and we don't think to explain why we do it because we are not aware. It simply was an emotional reaction that was correct in many cases 25 years ago, but today is not. Those are the primary things. Now, there's one additional aspect that's worth mentioning: security. There are times where security could play a role here. Pretty much the only time that would be the case is if you need to take one of those file systems and at the file system or volume level, which is roughly the same thing but not exactly, and you needed to, say, encrypt that volume. If you needed to do that, but you did not want to encrypt the other data, then having those things isolated so that one can be encrypted and one does not need to be makes sense to separate at a volume level. That would be absolutely logical. It is an edge case, but an easily identifiable and important edge case. So something to think about. However, when doing this, people don't tend to think about encryption. They tend to think about access controls. And access controls do not understand or care about the differences in file system containers. If you have 2 NTFS volumes, if you have 3 XFS volumes, the system doesn't care. It's going to give the same security rights to all of them because they all connect to the same security mechanism. It is not going to identify, oh, you have access to this file system, but not that one. That is not how that works. Unless you physically wanted to mount and unmount under different situations, that is probably not a good way to work with your data. So assume this is not a security mechanism. You do not use this to put one department's data onto one volume and another department's data onto another volume. You are not separating them in some security way. If you had access to one and wanted to get to the other, your access would be completely unimpeded by the fact that they are in separate file systems. The system would be transparent to that. The users would not even know they were traversing a different file system. That is not a good reason to be separating. Now, I do have a caveat to that. There is a scenario where different file systems carry different security capabilities. This is an extreme edge case, but it is real. You could, in theory, and let's say you're on Linux and you need to provide file services to a number of different devices. You may want to provide one file system for those who are on Linux and not have to worry about providing SMB or NTFS or other rather complex Windows security mechanisms to those users. The level of security remains the same, but the specific mechanisms are different. You could put a Linux native file system that does not support those things onto that file system, and you could have a separate, say, NTFS file system or similar that provides those services to Windows users, and they would have access to all their normal range of things. That's a viable reason, as are some really other quirky edge cases, such as changing your synchronization settings at mount time. Again, I don't know, in all my years of working in systems administration, while I know lots of people who are capable of making those kinds of decisions, I'm not aware of any of them who could be capable of doing so, actually looking at separate file systems and saying that they wanted to tune their file systems so specifically that it would justify splitting them in this way. That's just not very practical. What they are most likely to do is tune them, but tune them across an entire server, or have those workloads completely separate is what would often simply happen. It's really rare that you would need to tune in that specific kind of way, but it does exist as an option. So it's important to know. There's nothing wrong with splitting up your file systems. There are reasons for doing it, but you should probably assume that just out of the gate, none of those are going to apply to you, not just today, not just in a specific scenario, but over the course of your career. The chances that you will ever encounter such an extreme case is very unlikely, and every passing day makes it less likely as file systems continue to become more stable, continue to become more performant, continue to get bigger, as the underlying hardware continues to get more stable itself and to get faster and so forth. Those needs, while they've diminished to practically non-existent, will continue to push towards non-existent for the foreseeable future. So it's not going to get more likely as time goes on, it's going to get less likely. Thanks for joining me. Please remember to like and subscribe. If you'd like to support the channel, you can buy me a coffee. I'm going to put the link right here. That comes directly to me. If you have any questions or comments, please go down and join our community. put your comments here on YouTube or go on mangolassi.it or republicofit.com and leave your comments there. There's a great place for discussion. You can give feedback. If you have specific questions about what about your scenario, absolutely jump in there and ask. People like me will happily respond. Please share on social media, do all that stuff, support the channel. Thank you so much for joining us. I will see you all next time. There is an additional case as to why we may want to separate file systems, and I don't like this one, but it does make a certain amount of sense, and that is backups. There are a number of backup mechanisms or related to backup snapshot mechanisms. You can see my video, why snapshots are not backups. Everyone should be aware that they are separate concepts, but backups often, very often, leverage snapshots, and snapshots often leverage volumes. So if you have a volume, or in some rare circumstances, a file system with a snapshot mechanism, and don't be confused, things like ZFS and ButterFS and REFS, they do have snapshots. They are file systems. They are also LVMs. It is their LVM layer doing the snapshot, not the file system. That's a bit of semantics, but when we say we do it at the volume level, that is where snapshots happen. It is essentially impossible for a file system to take a backup. It needs the volume layer. It's not completely impossible, but no one is going out of their way to write a file system to do that when we have volumes that do it already. It's just that ZFS, ButterFS, and REFS have built their LVM layer into the file system as opposed to NTFS and XFS and JFS and ext4, who all rely on a secondary external LVM layer to do the work for them. It's just in one case it is bundled, in one case it is not. That is it. So when we want to take snapshots of a file system, that happens at the file system / volume level. So when we want to do that, we will limit ourselves if we put everything into a single volume, and we would say, well, we'll take all of our backups together. In many cases, we actually want that to have consistency for our backups across all of our data. When we go to restore, we can do a point of time, and the entire server or desktop or whatever restores as a single entity in a single point of time. If we have those separate, we have the flexibility to say backup one using a snapshot and another without using a snapshot, or to back up the file systems at different intervals or frequencies or with different priorities because they're able to snapshot independently. Both have their advantages. By far, the majority of people are going to lean to snapshotting a single thing rather than multiple. It is far less complex. It is much easier both to back up and to restore. There are advantages that could make backups drive you to the other. However, I will say, as I always say, proper backups are aware of the applications, and the number of times that you should actually be taking a backup as a snapshot approaches zero. It is not zero. It is a mechanism that can make sense in very specific circumstances where the administration has an extreme level of knowledge of their data, and or the organization has an extreme tolerance to data corruption and loss through their backup mechanisms. Under those circumstances, there are ways to use snapshots, but in general, we want to be taking backups at a higher level, and we don't need to snapshot. We don't need to rely on the file system. We don't need to rely on the operating system to do those things. So if we're doing it the way that we recommend, where it is fully application aware, all this is moot. But if you are, like most organizations, relying on mechanisms and backup software that operates without application awareness and just does its best to lock the file system, then having access to that file system locking and potentially tuning it may play an important role for you.